In this video, we're going to talk about integrals of trig functions. Going to solve a lot of them. But first, you need to know the rules. You can't play the game without knowing the rules. The derivative or sine of anything. The reason I have u there is because u is a function of x. Maybe u is x cubed plus 9x minus 11. Maybe it's log of x squared over the number 7. Maybe it's x plus 2 cubed times x minus 3. It's more complicated than x. Or u can actually be x. The derivative of cosine of any angle, the derivative of the sine of any angle is the cosine of that same angle. The angle doesn't change, times the derivative of the angle. The derivative of cosine of any angle is negative the sine of the same angle. The angle doesn't change, times the derivative of the angle. The derivative of tangent of any angle, that is going to equal to secant squared of that same angle. The angle doesn't change. U prime. You change the angle, you made a mistake. Keep that in mind. The derivative of secant of any angle, the derivative of that is going to be secant of the angle times the tangent of the angle times the derivative of the angle. It's going to have secant u, tangent u times u prime. The angle doesn't change. The derivative of cosecant of u is going to be negative cosecant of u cotangent of u times the derivative of u. Can't stress it enough. The angle doesn't change when you take the derivative of any trig function, including cotangent of u. The derivative of cotangent of any angle is negative the cosecant squared of that same angle times the derivative of the angle. You need to know these 6 rules. You can't play the game unless you know the rules. And you can't say, oh, calculus is hard. Of course it's hard. You have to know the rules though. That makes it a lot easier. The integral of the cosine is 3x squared times 6x dx. Well, if I let u equal to 3x squared, then this part here, that's going to be the cosine of u. And du, based on this, is 6x dx. Oh, I took care of this. That's cosine of u. What's left over is du. But this is one of the integrals we know. It's the sine of u plus c. So the final answer will be whatever the sine of u is plus c. And u is 3x squared. Suppose you have this problem. X times secant squared x squared tangent x squared dx. I like to let the angles be just x or y or u. In this case, since it's not x, it's x squared, I'll let u equal x squared. Well, then du will be 2x dx. Well, I have the x dx. I just need the 2. Not a big deal. I put in a 2. I bring out a half. So there's the half in front. This times that, 2x dx. Why, that's du. Let me just put that at the end. And then here I have secant squared u. And here I have tangent. I just want to see something, please. Okay, tangent u. So now I make another substitution. I will let v equal to the tangent of u. So that's going to be v. Why am I going to do that? Because dv is secant squared u du. So secant squared u du, I replace that with dv. So I have 1/2, again, this is v, integral of v, and this times that, that's dv. But that's a pretty simple integral. That's 1/2 v squared over 2 plus c. That is, it's v squared over 4 plus c, where v was the tangent of u, but I had to square it, over 4 plus c. And then lastly, we know that u is x squared. So it's tangent squared of x squared over 4 plus c. Let us go over a couple of other ones. Suppose you were asked to calculate the integral of the tangent of u du. Well, if it doesn't matter, but let's call it x, the unknown. And if I call that u, the derivative secant squared x is not there. What you should do in this problem is just say, you know what, tangent x is just sine x over cosine x dx. Well, if I call that u, I pretty much have du on the top. Not exactly, but within a constant. If u is cosine x, then du is negative sine x dx. And if I put a negative on the inside and a negative on the outside, that's okay. There's the negative on the outside. The bottom is u. The top is, because I know cosine x is u. And what's left over, negative sine x dx, that's du. And this is an integral that I know. The negative is still there. It's negative the absolute value of u plus c. And you plug in what u is, which is cosine x plus c. And there's your answer. Now, that one we were able to figure out. A couple of others, which is less obvious, is that the secant of x dx is equal to ln of secant x plus tangent x plus c. If you don't believe that, that's great. The derivative of this is, well, the derivative of ln of anything is you put the anything on the bottom and the derivative on top. The derivative of secant x is secant x tangent x plus the derivative of tangent x is secant squared x. The bottom, we're not going to touch. The top, we can factor out a secant x from both terms. The first one, we have tan x left over, plus the second one, we have the second secant x left over. Well, secant x plus tan x plus secant x, they're the same. So I get back secant x, exactly what I was integrating. The derivative of the answer should be what you're integrating. That is how you check if your integration is correct. The integral of cotangent x dx, don't need two d's. Well, cotan x is cosine x over sine x dx. Well, if I call that u, then that is du. U is equal to sine x. Du is cosine x dx. This one fit like a glove, no modifications or anything. The bottom is u, which is sine x, and the top is du, which is cosine x dx. Well, that's just ln of u plus c, where u happen to be sine x. Now this one, I won't prove it, but it's proven just like we did for cosecant. Take the derivative of our answer. This is equal to negative ln of cosecant x plus cotangent x plus c. Should know that. Okay. Now, let's do some integration. Suppose you were given this. I think the first thing you should do is, when an angle is more complicated than just x or y or t, is make a substitution. Let u equal x squared, and du is 2x dx. Well, this part will be cosine of u. The integral of cosine u. What's left over is x dx. Ooh, that's what I need, but I also need a 2. Fine. Put the 2 in, but bring out a half. There's the half that I brought out. 2x dx, that's du. I justified every piece. Okay, this is equal to 1/2 times this integral. The integral of cosine of u is sine of u plus c. So the final answer is 1/2 sine of x squared, because x squared is u, plus c. Suppose you have the integral of secant x cubed to the 5th power times secant cube x cubed plus, not plus, that's ridiculous, times tangent cube x cubed times x squared dx. Now, for the record, since these bases are the same and I'm multiplying them, I could have given this here as the integral. Okay, but I don't want to be that brutal. Well, the first thing you should do, so let's start with this. The first thing you should do is let u equal the angle. Then du will be 3x squared dx. So this part will be secant u to the 5th power, which I'll put there. This piece here will be secant cube of u. This piece here will be tangent cube of u. And then you have x squared dx. Well, if you had 3x squared dx, you'll have du. So I put the third in the front, and I have my du. That's du. Now, something is bothering me about this problem. I think what's bothering me is we shouldn't have this, which meant the top line is still correct. Okay. Alright, so we don't have these cubes. So now how do you do this problem? Well, if you call this v, the differential of v will be that. Let v equal to secant of u. So then dv will be secant u, tangent u, du. So that integral is 1/3. This is v to the 5th. This here is, well, this whole thing, secant u, tangent u, du, that's dv. This is simple. That integral is v to the 6 over 6 plus c, which is v to the 6 over 18, which is v secant u to the 6th power plus c. And this here is secant to the 6th power of u, where u was x cubed. And there is your answer. This one also fit like a glove. This here was v to this 5, and there's dv. Let us try some more. Suppose you have the integral of secant x plus 1 times tangent of x plus 1 dx. Well, you should let u be x plus 1, so then du is dx. So that's u. So secant u, tangent u times dx, which turns out to be du. Now, the real question is, what's that integral going to be? What's the integral of secant u du? Now, you should know this answer. That is, what did you take the derivative of to get you that answer? But if you don't know it, not to worry. What you can do is rewrite this. Secant u is 1 over cosine u. Tangent u is sine u over cosine u du. Well, this is the integral of sine u over cosine squared u du. And if you see what's coming, you can bring this to the numerator. and you get sine u du. Well, if I let v just be cosine u, then this here would be v to the negative 2, and then dv will be negative sine u du. Well, I have the sine u du, I just need the negative. So there's a negative in front, and negative sine u du, that's dv. But once again, this is a very simple integral. There's the negative. Add 1 to that power and divide by that power. Well, these negatives are going to cancel out, so you just have v to the negative 1, which is 1 over v plus c. But what was v? V was cosine u. What was u? U was x plus 1 plus c. And since this is in the bottom, then we move it to the top and make it secant of x plus 1 plus c. That is, if we knew our rule, this here is the secant of u plus c. And we said that u was x plus 1. And I would have been done. I did all this extra work because I didn't know what the integral of secant u tangent u du is. It's just secant u. And that's because the derivative of secant u is secant u tangent u. Know your rules. It makes life a lot easier to play the game. The game is calculus. Okay. Suppose you were asked to solve for this integral. The integral of 2 times theta minus the tangent of 2 times theta squared. Let u equal twice theta, so then du will be 2 d theta. Then du will be 2 d theta. Okay? So this will be secant of u minus the tangent of u all squared times d theta. Oops, I need a 2. So I put in a 2, and that will be du, but I have to take out a half, because a half times 2 is 1. Can only multiply by 1, otherwise you change the value of their integral. Okay. So now what I would do is, there's a couple of things you can try. There's the half. You can try writing this just in terms of sines and cosines. So then you get 1 over cosine of u minus sine u over cosine u all squared du. So there's the half. The bottom squared will be this. The top squared will be 1 minus 2 sine u plus sine squared u du. Well, there's the half. If I separate this into 3 integrals, I get the integral of 1 over cosine u, which is secant squared u, minus 2 times, I'm factoring out the 2 times the integral of sine u over cosine squared u. I think we just did this problem, plus the integral of cosine squared over cosine squared, which is tangent squared u. They all should have du. Okay, now we have this trig identity. We know that sine squared u plus cosine squared u is equal to 1. If I divide everything by cosine squared u, this becomes tangent squared u plus 1, because this is 1, and this is 1 over cosine, so it is secant squared u. So I'm basically looking at those two integrals. I want to see if I can make it nicer looking. For example, if in the end on one side I want to have tangent squared u plus, well, let's write it the way I have it. I want to add something, so we get secant squared u plus tangent squared u. Well, I have there tangent squared u. I need to add the secant squared u and then get rid of that 1. So now when I add them, I have secant squared u plus tangent squared u. The 1's cancel. But of course I have to do the same to the other side. And this gives us 2 secant squared u minus 1. Okay. So we get 1/2 the integral. Now I combine these two. There it is. And I get this. So it's 2 secant squared u minus the 1 du minus, let's not forget that, minus 2 times the integral of sine u over cosine squared u plus c. Well, let's not deal with the plus c yet. Okay, here's the 1/2. This 2 that I'm erasing can come out in front. Now, what is the integral? There's the 2. What is the integral of secant squared u? The answer is tangent u minus, what's the integral of 1 du? The answer is u minus 2 times something. The integral of sine u over cosine squared u. Well, if I bring the cosine u to the top, it'll be to the negative 2 times sine u du. Well, if I call that v, we have v to the negative 2, well, dv would be negative sine u du. So I need to put a negative in front, and then I have dv. And when I integrate this, I get negative. I add 1 to the power, I divide by that power. This cancels out, so I get 1 over v. And v was cosine u. So I get 1 over cosine u, which is secant u. Okay. Minus 2 times secant u. So let me erase what I wrote underneath here because I need the space. Now we're ready to answer this. Write down the answer. It's 1/2 the tangent of u, and u was just 2x, 2 theta. So it's tangent of 2 theta minus 2 theta minus 2 times the secant of 2 theta. That's plus c. That's one way we could have done this problem. Let's look at a second way. So the first thing I would do, no matter how I do it, is I make the substitution that u equals 2 theta. So basically, we just like to know what this equals. The right-hand side. Secant u minus tangent u all squared. What is this integral? Well, if I square it, I get the first squared minus 2 times the product of those two things, which is cosine u tangent secant u times tangent u minus tangent u squared minus tan squared of u all times du. Now, let us look at this. You have this minus that. Remember, we derived this formula. We derived that tangent squared u plus 1 is secant squared u. So, if I bring this to the other side, I get that 1 is equal to secant squared u minus tan squared u. Okay, so this minus that is just 1. Okay, so we want to integrate 1 minus 2 secant u tangent u du. Well, the integral of 1 du is u minus 2 times that integral. But the integral of secant u tangent u is just secant u. Okay, now, so the answer, u minus 2 secant u. There's one thing I didn't write down. Let's find it. I just found this integral. Our original problem, or forget that half for now and forget that too. Our original problem was half of what I just did. So I have half, and then I substitute u with 2 theta. 2 secant of 2 theta plus c. Just trying to find our last answer. For some reason, I'm just not seeing where the answer is. But what I can say is we can factor out a 2 from here. It'll kill off the half in front, and I get theta minus 2 secant 2 theta. Now, I want to point out something very important, because I know that this doesn't look like the solution that I got the first time through. And if it is, wonderful. Actually, I'd really like to see that last answer. Okay, so let's, I see it now. Let's modify our last answer. Okay, let's modify it. This is the answer we got, but we also know these two identities. They're the same. So what I have is tangent of 2 theta minus, I'm just going to take away one of those, minus secant of 2 theta minus the 2 theta minus that second tangent theta. Okay, now what is this minus that? Well, I have this backwards. I have it backwards. If you multiply this by -1, you'll get tangent squared u minus secant squared u. If I multiply the other side by -1, I get -1. So this is 1/2. This minus that is -1 minus 2 theta minus secant 2 theta plus c. Now, a half times -1 is a constant. It's -1. Oh, so I can call that the constant is really -1 then. I won't write c minus 1. But c minus 1 is any constant. So it's still plus c. And when I distribute this, I get negative theta minus 1/2 secant 2 theta. Now, I don't know why we're not getting the same answers. Okay, there's a mistake somewhere. I admit that. Okay, this is not the same answer that I got doing it the second way. But I do want to point out something. If you have the integral of, say, x plus 2 squared, you can say dx. One student can say, you know what, u is x plus 2, so du is dx, and this integral becomes, well, that's u squared, and dx, oh, that's du. I know, it tells me. So they get u cubed over 3 plus c, and u is x plus 2 cubed over 3 plus c. This is their answer. Another student says, I don't like this u substitution stuff. I'm not good at it. Well, this person squares this, and they get x squared plus 4x plus 4 dx, which is perfectly correct. Dx, and they integrate and they get x cubed over 3 plus 2x squared plus 4x plus c. And they look at this and they look at that and they're like, they don't look the same. In fact, let us go even further. Let's get it all over 3. You have x cubed over 3 here. You triple the top and the bottom. You get 6x squared over 3, which is 2x squared. Here, you get 12x over 3 plus a constant. Right. What I'm saying is 100% right, but it's just easier to deal with the first answer. Let's deal with the first answer. Let's cube x plus 2. So you're going to x cubed plus 6x plus 12. That should be x squared. So let's do it more carefully. You're going to get an x cubed, an x squared, an x, and then a constant. No 2's, 1 2, 2 2's, and then 3 2's. The coefficients are 1, 3, 3, 1. That's from Pascal's triangle. So you get x cubed plus 6x squared plus 12x plus 8. 12x plus 8 plus c. Okay. Let us just simplify just a little bit more. Let us do some of this division. X cubed divided by 3 is x cubed divided by 3. 6x squared divided by 3, that's 2x squared. And 12x divided by 3 is 4x plus 8 over 3 plus c. And now they're starting to look a lot similar, but they're not exactly similar. This one doesn't have the plus 8/3. Yes, it does. If this is C1, then that C is equal to C1 plus 8/3. The plus 8/3 is in that C. It's just a constant. C can be any number in the world. So can 8/3 plus C. You can get it to be any number. I can get 8/3 plus C to be any number, say K. How do I do that? I let C be K minus 8/3. Okay, if I want to get 11, I should let C be 11 minus 8/3, which is 33/3 minus 8/3, which is 25/3. Okay, and if this is 8/3, and I add 25/3, that's 33/3 in here. That's 11. I can get this to be any number I like, just like I can get this C to be any number I like. Get rid of this C and add it into this one. Now they look exactly the same. So two things can look different, but they just differ by a constant. Somehow, to be honest though, and I admitted this, somehow I don't think that our final answer in one of the cases differ by the answer we got before up here by just a constant. Minus 2 theta times the half is going to be, you know what, I don't know. Maybe they are the same. Let us look at this one more time. Okay, over here I'm going to look at it. I wrote down the half. There it is. Secant tangent 2 theta is right here. One of the minus secant 2 theta is here. Minus the 2 theta is here. And minus that other secant 2 theta is there. Now, we know that this is just a constant. So, when I have the C, I can just add that constant on. Okay, so how much different do they look like? Don't know where the error is, but it is easily found. Now, let us try one more problem. Two more problems exactly. So I want to show you again how you can do it right and get the wrong answer. Now, from 0 to pi. Now, if you wanted to do this problem, there's two ways of doing it. Both of them, in my opinion, are equally same level of difficulty. The u will be 2 dx. Well, I have the dx, I just need the 2. So I'll bring out a half. So what I have is the half in the front. That piece, every piece has to be justified for. That piece is sine of u. And then the 2 dx, That's du. And you should know the integral of sine u du. It is negative cosine of u, which is negative cosine of 2x over 2 from 0 to pi. Now I hate this negative. It drives me crazy. It really does. Well, I'm going to get rid of the negative, but I have to switch the limits. The pi goes down here and the 0 goes up there. So then I get cosine of 2 times 0 over 2 minus the cosine of 2 times pi over 2 equals cosine of 0 is 1 minus the cosine of the cosine of 2 pi is also 1. So we get 0. And let us verify that that makes sense. If you look at the sine of 2x, it goes from 0 to pi. That's one complete cycle. Okay, because when x is pi, we have to double it. So that would be the sine of 2 pi, which is 0. And when we double the other end, 0, 2 times 0 is 0. And here, this area and this area, they're equal. But one's positive and one's negative. So it makes sense to be 0. So that's another way you could have done the problem or thought about it. Now, like I promised, I'll do another way. Was the variable x? Yes. Sine 2x is 2 sine x cosine x. And actually, the last problem I wanted to do was the integral of sine x cosine x, because that can be done two ways. So I'll factor out the 2, and we're still going from 0 to pi dx. Now, one way of doing this problem is we can call that u, and then du will be everything else. So we have 2 times the integral of u du, which is 2 times u squared over 2, which is u squared, and u is sine x, and we have to square that from 0 to pi. Well, that's 0 and that's pi, and the sign is always 0. So you get 0 squared minus 0 squared, which is 0. But wait a minute. We have the integral of 2 times sine x cosine x. What if I call that u? If u is cosine x, then du will be negative sine x dx. We only have sine x dx. So I put in a negative, and I have to take out a negative. So what I have is negative 2, the integral of, that's u, and this times that is du. Well, that's a simple integral. Oops. That's u squared over 2. That's u squared over 2. The 2's cancel, so I get negative u squared, where u is cosine x from 0 to pi. If I get rid of this minus sign, I can change the limits. So I get the cosine of 0 squared, which is 0. No, sorry, which is 1, minus the cosine of pi squared, which is also 1. 1 squared minus 1 squared is 1 minus 1, which is 0. Now, what I want to show you is that what if there was no limits? what we discovered was that the integral of sine x dx, let me write it down twice, the integral of sine x dx, the first time we did it, we got this answer. Okay, what if there were no limits? What if there were no limits? Oh, you mean it's sine squared x? Yes, it is sine squared x. Just want to see one thing. Okay. Now, over here, the second time, remember, we got negative cosine squared. We got negative cosine squared x. They surely don't, plus c, plus c1, plus c2. Well, we know that sine squared x plus cosine squared x is equal to 1. That means, for example, sine squared x, bringing this over, is 1 minus cosine squared x. So this is 1 minus cosine squared x plus c1. But that's just minus cosine squared x plus c2. Oh, c3. Why c3? 1 minus c1 is just another constant. Okay, let's try to write this so we all can see it. So, we know that sine squared x plus cosine squared x is 1. That means that sine squared x is equal to 1 minus cosine squared x. I just bring the cosine squared x over to the other side. I get the sine squared x is 1 minus cosine squared x. So I get sine squared x, or that's 1 minus cosine squared x, plus c1, but this is negative cosine squared x plus 1 plus c1. Let's just call that c. And this is, well, I don't have to write it. Notice that these are the same answers. These are the same answers. Now, what's a quicker way of showing that? What if you didn't have this identity? The quickest way of showing it is to show that one answer without the constant minus the other answer without the constant, is a constant. The difference between the two answers is a constant. Well, this is sine squared x plus cosine squared x, and that's the constant. The two answers, this answer and this answer, they differ by a constant. I know it does. I took this function and I took away this function, there it is, and I got a constant. The two answers, they look drastically different. They look different, but they're the same integral. Okay, that finishes this section on integration. Integration of trigonometric functions. Did a lot of work here. Look at this.